Alright, cool. So remember, like I said at the end of the last video, keep in mind I may do these in a little bit different order, but we should get the same answer in the end, and you can ask me in tutorials or email me or something like that if you don't know why your way did not work, okay? So here we go. Alright, number one, there's only one number 2, and there's no other number to multiply it with, so I know I'm going to have 2 in my answer, and then these bases are being multiplied. Now, I would go ahead and this x to the 0, this I would simplify right off the bat. That's a 1, and so therefore it is gone. And all that's left behind is x to the 3rd. So that's how I would do that. Number 2, same thing. There's a 2 here, but no other number to multiply it with. And then we have 2 bases, so we add their exponents. So 2r to the 5th. Back here, same thing. A to the 0 is gone, and it only leaves an a behind. So that is your answer. Right here, I'm going to multiply the numbers together and get a 6, and then we have p squared times p to the 0. Well, that's gone. And then we have a p squared. If you've been messing these up, if you canceled out the whole thing into a 1, the reason that is not correct, guys, is because there's no parentheses around this term. If there had been parentheses to the 0, then you could cancel it all out. Otherwise, the 0 only goes with who it's immediately touching, okay? Now over to this. Okay, we got a lot of b's going on. I've got a b3 plus 2 plus, there's an invisible 1 right there. So this would be b to the, is that 6 of them? Yep. And then on the a's, there is a 3, and then there's another 3. So this would also be a to the 6th. So that would be my answer on 5. Number 6, I'm going to multiply the two numbers in the front together. I'm going to put a little 1 there so I know what power I'm dealing with. So I've got m to the 3rd and n to the 5th. That's just adding exponents. Over here, I've got a 2 times 3, which is a 6. I've got an x to the 1st and a y to the 1st, and nobody to put them with. So that would be how you write your answer, because you just recopy, because there's no other math to be done. I've got a 3 times no other number, and then I've got a, 2 of them here, 1 of them there, so it's a to the 3rd. And then b to the 0, that guy is gone. So that would be my final answer on that. Now, hopefully 1 through 8 went okay for you. If not, go back and rewatch this and see where you went wrong, because they only get harder from here. So we start with number 9, and the way I'm going to do it is the power to the power first. So I'm going to recopy the m to the -3, and then it's going to be times m to the, that would be a 5 times 3, which is a 15, and then n to the 9th, because it's a power to a power, so you've got to make sure you distribute that 3 to both of them, okay? Then in the end, I've got 2 m's, so I get to add their exponents, so that would be, what would that be there? That would be equals m to the 12th, n to the 9th. Okay, over here we've got a 2 on the outside, and it's going to go to everybody on the inside. So this will become v to the 4th times negative u to the 10th times v to the -4th. So notice I'm just distributing the 2 to all the exponents. Now I've got 2 v's, so I can put the v's together, and their exponents add up to a 0, which means they are gone, and I just have negative u to the 10th. Final answer. Number 11, same thing. I'm going to take that 2 and bring it on into everybody on the inside. Now, actually, you know what? I'm going to do it a little different to show you that you can. If you want to work inside the parentheses first, then distribute that 2, you can. Because, look, I've got a U5 and a U5, so that's really a U10. And then a V to the 0, that's gone, and a V to the -4. So if you want to do what's on the inside first, then distribute that 2, you absolutely can, because if PEMDAS you're still in parentheses, then you're going to handle that outside exponent. Alright, so now it's u to the 20th and v to the -8th. Now we don't want to leave our answers with a negative exponent. It's okay to have a negative in front, like on number 10. But a negative exponent, you want to rewrite that. So it's really u to the 20th over v to the 8th. And that would be how I write my final answer. This turns into its reciprocal, which moves it to the denominator, and that's why it looks like that. Alright, right here, I'm going to take -5, distribute it to both. So remember, there is an x with an invisible 1 here, so it should be x to the -5th, y to the, what is -4 times -5? That would be +20, and then x to the -1. So what is an x to the -5th and an x to the -1st? Well, that's an x to the -6th times y to the 20th. And once again, I have an ugly negative exponent, so I'm going to keep the y20 on top, and then the x to the 6th is going to move down below because it's got a negative power. Okay, number 13. Let me distribute that 5 to the inside. Y to the 5th, x to the 25th, and then a negative x to the 3rd. So that negative, I'm just going to recopy that negative in front of everybody. I'm going to recopy the y to the 5th, and now x to the 25th and x to the 3rd would be x to the 28th. So view that negative not as being part of that exponent. You know, that negative is like there's an invisible -1 in front of that. So that's why it's okay to bring it to the front of everybody. Okay? Number 14, I'm going to distribute. So actually, I'm only going to distribute it to one of the things because b to the 0 is gone. So this is really a to the -5 times a to the 3rd. Once again, that's also gone, b to the 0, because it's just a 1. And now I put these together and get a to the -2, which can be written, or should be written, like this because of the negative exponent. Okay, we're almost there. Last 4. Okay, so number 15, I'm going to first handle, I see a lot of zeros. So I've got n to the 0, so this term is gone. And then I see all this junk to the 0, so all of that is gone. So it looks like I'm left with a 2 on top and an mn to the 4th on bottom, and that's it, folks. Nothing else goes together, so that turned out to be pretty easy, actually. Okay, right up here, I'm going to go ahead, same thing. On the bottom, all that is raised to the 0th power, so it's all a 1. And then on the top, I've got an x to just the first, a y4, and a y to the -2nd. Well, the rule is to add those together, and that's what you get. So you're done on that one. On this one, I'm going to go ahead and distribute the 3. And this is where I'm afraid some people will mess up. They'll forget to do the 2. You need to do the 2 to the 3rd, and that's an 8. And then that would be y to the, now you multiply these two. So make sure you get that 2 to the 3rd and then y to the -3rd. Okay? And now on the bottom, let me see if I can group anything. Okay, on the bottom, you see these x's? I'm going to go ahead and put those x's together by adding their exponents. And that's how I chose to handle that one. Remember, order, you might have done something different, but we should have the same thing in the end. Now I'm going to reduce the numbers. So 2 goes into 8 4 times. And then I've got a y on top and a y on bottom, so I'm supposed to subtract these. -3 minus 3 is a -6. And then I've got all of that over x to the 5th. Okay, I hope y'all saw that happen because the x to the 5th was in the denominator. It can't just jump up to the side. It needs to stay in the denominator. Now when I did this y to the -6, I went ahead and wrote it in the numerator, but now I can do that thing where I move it because really a -6 exponent should move to the bottom as well. So my final answer should look like that. We can talk about that or do more examples of those if you need to, but that's how that one turns out. And this one will probably be equally difficult. Okay, I've got an x to the 0. Let me cross that out early. Any other zeros? No. Okay, so I'm going to handle the -4 first because it's going to both of those, okay? So what that's going to be is on the top, I'm going to have, let me recopy this. I have a 2y to the 3rd. That's going to become 2 to the -4th, okay? Now, that means it's 1 over 2 to the 4th, which is what? You know what? Let's do this a different way. I'm actually going to write, I want to show y'all something. So let me write this as 2 to the negative 4th, and then y to the negative 4th. And then on the bottom, I have x 4, y negative 4. Okay, here's what I want to show you that's actually really pretty cool. We have not done a problem yet where we have seen the numbers being the same. But look at this, a 2 and a 2, these are the same base. This does have an exponent of 1 on it, so we can do the same rule with those that we do to variables. So we can actually call that 2 to the, and we can add these exponents. 2 to the negative 3rd. And then we can also, in the same stroke of genius, instead of putting these two together, do y'all see right here how these match exactly? Well, why not cancel them out? If something matches exactly with what's on the bottom, it's just like a 1, right? So I'm going to go ahead and get rid of those. So now I've only got a y cubed on top and an x to the 4th on bottom, and the only thing left to figure out is this mess, right? Well, 2's got a negative exponent, so where does it need to move? It needs to move to the bottom as a 2 to the 3rd. Now, I'm not going to leave it like this because 2 to the 3rd we can totally do, right? That's just 2 times 2 times 2, so that's just an 8. That's how I would write my final answer. Now, if you got that one right, give yourself a high five, pat on the back. If you didn't, we can talk about it. You can email me. We can do more examples. It's tough. It's tricky. There's a lot to keep up with, but hopefully some of you did figure it out. All right, we will see you later.